Hi, we are in part 2 of linear functions, section 4.2. We were just beginning this example on interpreting slope. A city's population in the year 1960 was 287,500. In 1989, the population was 275,900. Compute the rate of growth of the population and make a statement about the population rate of change in people per year. So they want us to find the slope and interpret it. So first, it looks like they give us 2 points. So the first point is in 1960, there were 287,500 people in the population. Then in 1989, the population was 275,900, so that would be a second point. In 1989, there were 275,900. It looks like the population is going down. Now, if you remember, to find slope, you find the change in y, or the change in output values, over the change of input values. So to use that formula first, I'm going to label my points. This will be point 1, and so therefore this will be x1 and this is y1, and this is point 2, so this is x2 and this is y2. So if you will recall, the formula, m is slope, is the change in output values, so y2 minus y1 over x2 minus x1. So now we just need to fill in this formula. So on the top we have y2, which is 275,900. That's y2. That's going to go right there. So I'm going to put that in. Then I have minus y1. y1 is 287,500. And then that is divided by x2 minus x1. And x2 is 1989. Minus x1, which is 1960. So we have 275,900 minus 287,500. And when we subtract that, we get a negative number, negative 11,600. Then when we subtract 1989 on the bottom minus 1960, we get 29 years. So then we can divide this 11,600 divided by 29, and we get negative 400. Now that is our slope, but we need to interpret it. So first we need to interpret it using our units. So our y's, what did those represent? Those were the population. So that's, I'm guessing, people would be that unit. And then the x's, these were years. And then, as I told you before, we can just say this is per. So people per year, it's negative 400 people per year. So it looks like when they say make a statement about the population rate of change in people per year, which they kind of gave us that hint there. So I know we're right when I say people per year over here, because that's what they have written in the scenario. So it looks like people, or let's not say that, let's say the population, because that's what the function is about. The population is decreasing by 400 people per year. So the population is going down, and this is a function that is decreasing, and we know that because the slope was negative. So not only did we find slope, we also interpreted it. All right, so now we're going to let you try it. So take a look at this, try it, pause the video, attempt to find the slope, and interpret what the slope means. And when you come back, we will go over what the answer is. Okay, so hopefully you paused the video and you tried this problem. Now we're going to go over it. It says the population of a small town increased from 1,442 to 1,868 between 2009 and 2012. Find the change of population per year if we assume the change was constant from 2009 to 2012. So first, let's identify our points. So it was 1442 at the beginning, and it looks like the beginning was 2009, or the beginning of this scenario, rather. And then it increased to 1868 in 2012. So we say 2009 is the beginning because that's when we start paying attention to how much it increased. So from 2009 to 2012. So our points are in 2009, it was 1,442, and then in 2012, it was 1,868. So the first point is our first point. We call it x1 and y1. This is our second point. We will call it x2 and y2. And recall the formula for slope is y2 minus y1 over x2 minus x1. So we would have 1,868 minus 1,442 over x2, which is 2012, minus 2009, which would be x1. So on top, 1868 minus 1442. I believe we get 426, and on the bottom, we get 3. And then when we divide that out, that is 142. So, and that's people for the y per year for the x. So the population increases because it's got a positive slope, plus it says it increases. It increased. It increases 142 people per year. Okay, so now we're going to move on to writing and interpreting an equation for a linear function. So how to, given the graph of a linear function, write an equation to represent the function? Well, let's just say first, to write a linear equation, you really need 2 items. And those items are the slope and the y-intercept. Now, sometimes they give us both of those, like they have like in the train scenario, it actually gave us both of those items, but it doesn't always happen that way. So if it doesn't, what you need to do is you need to identify 2 points on the line. because if you have 2 points, then you can find the slope. So using those 2 points, you calculate the slope. So you have the first thing that you really need, and then determine where the line crosses the y-axis to identify the y-intercept by visual inspection. So you need the y-intercept, and then you substitute slope and y-intercept into the slope-intercept form of a line equation. So let's take a look at this particular graph. And that's really how we do this with everything. You need these two items. Just going back real quick, you need slope and y-intercept. So your goals are always to find both of these numbers, and then you can write the equation in slope-intercept form. So writing an equation in slope-intercept form, so you need the slope and the y-intercept. So I always start with the y-intercept because it's visually you can see it. It's right there. This is where it crosses the y-axis. So we are locating our B, our y-intercept. Okay, that is the point 0, 3. So in this case, B equals 3. So the next thing we need is the slope. So to find the slope, we need 2 points. So I already have 1 point plotted here, so I'm going to plot another. Now you have two options. Option 1, you can label your points 0, 3 and 1, 1, and then you can come over here and do point 1, point 2. You can do y2 minus y1 over x2 minus x1, we get negative 2 over 1, which is negative 2. The other thing you can do with a graph that's small like this is you could actually use rise over run. You can actually count because you can physically see the change in x's. So the x's change negative 2, and the y's change negative 2, and the x's change 1. So if you think of it as rise over run, it changes negative 2 over 1, which is also negative 2. So either way, you find the slope, and you find that the slope is negative 2. So now we know enough to write our equation in slope-intercept form. We needed these two things, slope and y-intercept, and now we know them. F of x is equal to negative 2, because that was our slope, x plus b, and b is 3. So just fill in the m and the b, and you have your linear function. Okay, next we have a try it, but I'm going to go ahead and try this one with you because it's a little bit different than the last one. It says, if f of x is a linear function with f of 2 equal to negative 11 and f of 4 equal to negative 25, write an equation for the function in slope-intercept form. So we need two items. We need m and we need b. They don't give us either one. So we're going to do that first step. We're going to find the slope. So I started with finding the y-intercept on this particular one because I could see it. But with this current one that we're on, we can't see the y-intercept, so we're going to start by finding the slope. Now the 2 points are 2, negative 11, and I don't know if you can see that, so let me scroll down a little. 2, negative 11, and 4, negative 25. They were just written in function notation, so 0.1, 0.2. So slope is y2. So let me just write that down so everybody will remember. Slope is y2 minus y1 over x2 minus x1. So in this case, we have negative 25 minus negative 11 over 4 minus 2, which is negative 25 plus 11 over 2, because 4 minus 2 is 2. Negative 25 plus 11 would be negative 14 over 2, and we get negative 7. So negative 25 minus negative 11 is the same as negative 25 plus 11, which is negative 14. 4 minus 2 is 2. Negative 14 over 2 is negative 7. So the slope in this case is negative 7. Now we need to find our b. So there's actually two ways to do this. So we have the slope intercept form method, and then we have what is called the point slope form method. So slope intercept form, we start off with our slope intercept form. So I'm just going to replace the f of x with y for right now. Just look at it as an equation form. And what you're going to do is you're going to sub in x, y, and m. So what you're going to do is you're going to pick one of these 2 points up here. Either the first one or the second one, it doesn't matter. Either one will yield the same answer when we're finished. So just pick a point. I'll just pick the first one. So in this case, x equals 2, y equals negative 11, and we just found m, that's negative 7. So we're going to substitute each of these into the equation. So y is really negative 11 equals m, which is negative 7, x, which is 2, plus b. And what we're doing here is we are doing this so that we can figure out what b is. So we're going to solve for b. So negative 11 equals negative 14 plus b. So then we will add 14 to both sides. And on the left, negative 11 plus 14, I believe, is 3. On the right, the negative 14 and 14 cancels and just leaves 3. So when you're finished, you fill in y equals mx plus b. And m in this case was negative 7 and b was 3, which we would write in function notation like this. Alright, and so that's pretty quick. But I did want to show you there is another form that you may have used in the past. It's point slope form. This ends up with slope intercept form in the end. Okay, so this formula is y minus y1 equals m parentheses x minus x1. So you still have to go and find the slope first, and then you still have to take one of the points at the top and sub it into here for x1 and y1. So you're going to, in this case, you're going to replace m, x1, and y1, and then you are going to put it in slope intercept form at the end. So we have y minus. Now, which one do we want to use? We'll just go ahead and use the same point, just so you can see, use the same point and get the same answer. So we're going to use this right here. So y1 was negative 11 equals m, which is negative 7, parentheses x minus x1, which was 2. So on the left, I have y plus 11 equals, and then you have to distribute. Negative 7 times x is negative 7x, and negative 7 times negative 2 is positive 14. And then your goal is to get this y by itself, so you need to get rid of that 11. So you're going to subtract 11 on both sides, and we end up with y, because the 11's cancel, equals negative 7x plus 14 minus 11 is 3. So either way, you get the same answer in slope-intercept form. On the left-hand side, you start off with the y equals mx plus b. and then you plug in, choose one of these two, plug it in for y and x, and then sub in your m. So you need to find slope first, and then you use that to solve for b. Once you do that, you have slope, you have y-intercept, you plug it in, write it in function notation. That was the one thing we haven't done here yet, so this is, there we go. Okay, so on this side, this is point slope form, y minus y1 equals m times x minus x1. What's nice about this formula is you don't have to worry about plugging everything in and then taking your answers and plugging them into another formula. When you use point slope formula, you just plug everything in and then you simplify it and get y by itself, and then you're done. So y minus y1 equals m times x minus x1. You plug in one of your y's and one of your x's, as long as they're in part of the same point. So I could have put in y minus negative 25 equals negative 7 times x minus 4, and I should have gotten the same answer. And then we get y by itself. And then we're done. Either way, you get the same answer. So I will accept either method. Whichever one you are most comfortable with is fine with me. Okay, so we will pick up with part 3, where we will talk about modeling real-world problems in the next video.